Once again, I welcome you on. Just to test, I want to make sure everybody can hear me. Can you hear me perfectly? Mazuli, uh, excuse me, who is with the Techno Spark 5 Pro? Please, can you change that to and put your name? Please try changing the name of your device and putting your name so we can be able to address you. Right. During our last session, we were talking about the general IT, what the program is going to entail, everything we're going to be seeing as we proceed. We talked about the computer as a whole, the components of a PC, how they interact among each other to make a system that facilitates human life. We did see how computer takes inputs, processes them, and provide them as output or stores them. And it also, and as well saw the different types of storage media that we use in IT. Please, can you mute yourself? Thank you. All right. So we talked about input devices, the various types of input devices. For example, we did talk about touch screens, mice, keyboards, etc. And we also did talk about processing devices. And yeah, so those are some of the things we did talk about last week. So as of the previous session, you guys had the recording. Did anyone go through and face any difficulty? Can you bring it forward so we can go through it before proceeding to the next session, the next step of this session? Any question with respect to our last session? All right, I'll take that for everything was understood. Once again, today is chapter 2. We're going to take on the as of the 13th of October 2023. We are beginning with chapter 2 that entails the responsibilities of a PC technician. So we are going to be seeing today on the first section what is protection and safety. We're going to be seeing how you as a PC technician is going to be faced with issues that you're going to solve, but how do you protect yourself while you're solving these problems? Right now, some of the key terms we are going to discuss within this submodule will be capacitors, electrostatic discharge, and peripheral devices. Further ahead, we're going to see what is a capacitor as per this definition. We say a capacitor is a device that stores electricity as an electric charge. An electrostatic discharge is the flow of electricity from one electrically charged object to another. So when one object is charged and you touch another object, which is not as charged as the previous one, electricity moves between them. So that is referred to as electrostatic discharge. Take, for instance, you walk through a room on a carpet with your socks. The friction between you and the mat causes electricity to build up. Any metallic object that you touch at the end of your walk will move the electricity that is in you into that object. So we refer to that as electrostatic discharge. Last but not the least, we have peripheral device, and it is a device that connects to a computer, such as a monitor or printer. In short, any device that you connect externally to a computer, that means a device that did not come by default with that computer, which you're supposed to plug in, is referred to as a peripheral, irrespective of what it is. Is it a monitor? Is it a printer, a scanner, a speaker? All of them are referred to as computer peripherals. We are going to begin this submodule with the concept of safety. So in general, what is safety? Safety entails how you keep yourself from being hurt or damaging components within your workspace. That's a general perception of what that term is all about. Now, while you're working with electronics, some of the first things you should start by doing is removing any jewelry that is on your body, any jewelry that you're worried that you're putting on. Are there wristwatch? Are there bangles? Are there earrings, nose rings, any jewelry at all that you're putting on? You have to take it off. That is to avoid electricity moving through a part that is not supposed to protect you yourself and protect the components that you're working on as well. So whenever you begin to work on any PC, you have to make sure that you have removed every metallic object from your body, anything metallic. So that's why we generally refer to them as jewelry. You also have to make sure that the grounding pin of the device that you're working on is connected. Say, for instance, you're working on a device that needs to be on while you're working on it. Say, like in the server, you're working on a server and you're doing some repairs. The grounding pin, just before I continue, the grounding pin that you see here is the third pin that is always found on these connectors on the that you use to plug in electric outlets. The third pin it is used to. Please, can you mute yourself?
I buy my own for Douala here. I know as I just go Douala there, I just turn around and see am. I just because if any person go buy price for
the grounding pin is the third pin that is found on every electric outlet that you use to plug in. That makes sure that if there is any electric discharge, it should pass through there and go to the earth cable without having to damage any electrical component. So always make sure that the pin is there and it is connected, because sometimes it is damaged, sometimes it gets destroyed, and it puts your devices at risk. And if electricity turns to come at a higher voltage or abruptly just spikes, maybe due to a thunderstorm, when like thunder strikes, if electricity comes at that high voltage, there will be no way for you to eliminate that electricity, and it will go through your device, which is not meant to sustain that kind of high voltage. So it will damage this device. So for you to be safe and your device, for the safety of your device and yourself, always enable that every device with 3 connectors is connected to an adapter or a power outlet that has three outlets or 3 connectors. Furthermore, on portable devices or most computers that are not servers, always make sure that before you start to do any work, any maintenance work on them, before you start to do anything that enables you to touch the internal components, make sure that this device is disconnected from power. Always make sure you unplug it before you start working on it. So if you have like a desktop computer and you need to change the RAM inside, or you need to change the hard drive, always make sure that the power cable is disconnected from the wall. All right, make sure it is disconnected from the wall. Next, if you're working on a laptop, the power source here is the battery. Enable to disconnect the battery before you do any work of any maintenance work inside the computer. So summarily, we're saying that in order to enhance the safety of your device and you, the operator, enable to disconnect power from your devices. And in cases where you can't disconnect the power from these devices, always enable to make sure that the power connector that has 3 pins, enable that it is plugged as well on a wall outlet that has 3 pins, so that the grounding pin should always be there working. Your manufacturer will not give you a device that needs 3 pins and you make it, you plug it on an outlet with just 2. It means the third one, the grounding pin, which is actually very necessary, is not working. If there's any surge, any electrical surge, which means an abrupt increase in the voltage that is coming to your outlet, if there is an abrupt increase, that power will pass through your device and will damage its components. But with the presence of that third pin, you'll find yourself being safe and your device as well. Next, when you are for your personal safety, this here is for your personal safety. There is this component inside your CPU or your computer's case that is referred to as the PSU. We call it the power supply unit. During our previous session, for those who were present and those who went through the recording, you will find out that we identified the PSU as one of the components of the computer. And this is the unit that collects electricity from the power outlet on the wall and then converts it to a format that can be used by the PC components. Remember, electricity that is coming from the wall directly is referred to as AC current. AC stands for alternating current. And electricity that your PC components need to work or need to function is referred to as DC. And DC stands for direct current. Now, here comes the PSU. The role of the PSU is to convert AC current into DC current. That means converting alternating current into direct current. There are times when your PC will start malfunctioning and you will troubleshoot the issue and detect that it is coming from the PSU. The trouble is from the PSU. It is either not working or not functioning properly. Avoid maintaining this component. Avoid making repairs on it. If it is bad, just simply replace it. Buy a new one and properly dispose of this one. We are going to talk in the further subsections of this presentation how you should manage to discharge to dispose of electronic components. So as of this PSU, do not maintain it. So every time you have an issue, you use it in your office, use it in your personal computer, wherever it is at work, make sure that you don't carry out any maintenance works on this particular unit. This is the reason why. It has high voltage capacitors that can keep electricity in them for a very extended period of time. This means that when electricity goes away from the power source, this component is capable of storing that current and transferring it to the next conductor as soon as it comes in contact with it. So you know that the human body is conducts electricity. So if you try doing maintenance on this particular component, the electricity in it is enough to kill you. There is enough electricity stored in these capacitors that can kill an adult human being. So all in all, do not maintain this component and rather replace it. While you're working with high voltage components, why do we refer to as high voltage components? These PC components that require high amounts of electricity to function. We just talked about the PSU, which is the power supply unit. We just said that you need to replace it instead of trying to do maintenance work on it. So some of the keys that you have to concern, some of the key tips you need to consider while working on the PSU is to avoid servicing them. So any component that takes high electricity, don't service it. If it's bad, throw it away and get a new one. Next, don't wear ESD wrist straps. We are going to talk about this particular component with this particular thing in subsequent submodules. We're going to talk about what is ESD in general and what are ESD wrist straps. Just so you know, ESD stands for electrostatic discharge. It's what we've been talking about just now. Also, to enable your safety, you is using the PC. While using computers, just excuse me. Remember that computer is not just what you use to watch movies, play video, play games, and all the stuff. It is not just a laptop or a desktop. A computer is any electronic device that is capable of receiving input, processing it, and giving it out as output. And we do know that a printer as well is able to collect input, process it, and present it as output. So while working with these computers, that is laser printer in particular, some tips that you're supposed to consider for your safety are So avoid laser lights. Laser printers use highly concentrated beams of light to write characters on paper. As a PC technician, while troubleshooting these devices, avoid direct contact with these lights. There are enough to damage your skin or your eyes if they get in contact with. So if this light go into your eye, they are enough to make you blind. And if you expose yourself, your body, directly to these lights for an extended period of time, you might even get risk of getting skin cancer. So while working or servicing printers, avoid direct contact with the laser light. Secondly, avoid inhaling the toner. The printer toner is the black dust, or irrespective of the color, is the ink that PCs use to print on paper. Avoid inhaling that. The toner is, how will I say? It is so light that it can float with the least movement. So for the least movement can make the toner to kind of evaporate and stay in the air, which if you inhale is very toxic. It can cause some health complications that we don't want to. So avoid inhaling the toner. There is this component inside a printer that is called the diffuser rollers. They are responsible for applying heat on a paper so that when ink touches it, it sticks. They generate a lot of heat that is capable of heating a paper. So while you're servicing this component, make sure that you unplug the printer from electricity, from power, for a period of time, such that it should cool down before you do anything on it. Because if you work on a printer that has its diffuser roller still very hot, you risk getting hurt. You risk hurting yourself, or burning yourself directly. If you touch these things, you burn yourself. Next, last but not the least, one of the tips that you should consider while working on printers for your safety is to avoid moving parts. You will most likely have to plug some components on electricity to see how they behave while they are working. So you might be tempted to touch some of these parts when they are moving. You shouldn't do that. You are not supposed to touch any component of a computer that is moving. It could either get damaged or hurt you as a person. So for your safety and the PC safety, do not touch moving parts inside a computer. There is a type of printer other than the laser printer, which is called the dot matrix printer. It uses hot rods to burn the paper slightly in order to imprint the characters on them. While you'll be going through the training platform, and you'll be looking at I'll be watching the videos and all the other tutorials that are present, you will learn about the different types of printers that do exist. I think we do have inkjet printers, laser printers, and there is a category that is referred to as impact printers. You're going to see that as you go through the test out platform. So before I continue, I would like to just take a short moment to ask you if there is any question that you have. Do you have any worries so far? Is there anybody with a question? All right. We are just going to continue. We're going to continue from here. And yeah, I believe as we proceed, you definitely have questions. Another aspect of safety is that while you're working with, generally, avoid any laser light that is being emitted from the PC. Any light that is very small and bright is referred to as laser. Avoid direct contact with this light, irrespective of the PC component from which it is coming from. It could be the optical drive, it could be from a fiber optic cable, or from a laser printer. Just avoid direct contact with your eyes. This is what a fiber optic cable looks like, and that is what laser light looks like. Just try to avoid direct contact with your eyes. Another aspect of safety that we need to do is proper cable management. Proper cable management. When you look at this particular environment, it is very likely, you notice that it is very likely for a hazard to come up here and propagate to other sections of the building. The cable management is very poor. And if you even look at this particular angle here of the wall, you see that the electric outlets are not even well seated into that. It is very into the wall. It is difficult for someone to plug and remove without being electrocuted. So while working with PCs or with cables, you should enable to carry out a proper cable management criteria. Enable to get a proper cable management table or resources. There are some tables that come already arranged in a way that you can send your cables through it and organize it in such a way that they are not just scattered all around as we see this particular scenario. This can cause physical hazards. If a cable catches fire, it's going to propagate to other cables, and hence we'll find ourselves with a physical hazard. Another concept that we are supposed to consider for our safety as we work with computers is lifting hazards. These are damages that you incur because you're trying to lift heavy objects without proper security or proper preparation. We realize that some CPUs are very bulky and heavy, while others are small. In as much as you have small ones, don't minimize it. Always use proper lifting methods before displacing them. In the case of printers, we all know that printers are very heavy devices. And if you have to lift them, here are some tips that you're supposed to consider. If necessarily someone cannot assist you, if you need to lift these devices from one place to another, you should consider the following tips. Lift with your legs and not your back. Some people tend to stand straight up and bend their waist and try lifting something with their spine. It is very wrong to do that. Irrespective of what you're working with, rather lift with your legs and maintain a vertical spine. Keep your spine straight, go down, bend your knees, carry what you're carrying, and then stand up with your knees. Don't use your spine to lift heavy objects. It can cause a hazard. Next, wear a back brace. There is a specific type of belt that you can wear on your waist that will help give you more strength and provide more tenacity or more support for your spine as you're lifting heavy objects. So you should wear a back brace when you have to lift heavy objects. Next, we also have carts, like shopping carts that we use in supermarkets. You can use them to transport heavy objects. You simply lift it a little bit, and by using your legs or back brace, lift it a little bit, put them in the carts, and push it to wherever you need to carry it to. Last but not the least, there are always people around you could ask help from. You cannot try to lift a heavy printer all by yourself. You should always be able to have someone that could give you a helping hand in order to lift these heavy devices. Also, we should always have a fire suppression kit. In this case, we're looking at a fire extinguisher. It is a device that is capable of diffusing CO2 within fire incidents in order to prevent them from from propagating or going to other components. So always make sure that in any setting where you have electrical components, you make sure that you have a fire suppression kit. All right. So as we continue in this submodule of safety, we are going to discuss how you manage to dispose of or manage cases of hazard. How do you dispose devices that are no longer needed? And how do you manage cases, incidents of where the hazards have already occurred? If the hazard occurs, how do you manage it? And in the case where you need to dispose of a particular component, how do you do that properly? There is this document that we call an MSDS, full meaning of Material Safety Data Sheet. It is a document that provides everything that you should do for every PC component in terms of hazard, physical data, in terms of its components, how it reacts, and the health hazard assessment. So things like if you get hurt like this in this particular way, how do you manage it? So the MSDS contains all this data. Say for instance, you're working with alcohol, a particular type of alcohol, while cleaning your PC, and it enters your eye. The manufacturer of that particular of that component will provide an MSDS on their website that is going to tell you how you assess health hazards. You can see at this or the section 6, bottom of this page, how you assess health hazards when they have already occurred. Generally, always for every product that you get online, the manufacturer provides you a document which is referred to as an MSDS, which will provide you every single instruction or tips on how to use their device. Summarily, we've talked about how to maintain safety as top priority when working with PC components. How do you fix hazardous situations? Who do you talk to within what is within your responsibility, and how do you report the things that that are above your responsibility? There are cases where what you're supposed to do is not within your responsibility or in your job description, and you need to report it to the next person who is responsible for that. How do you enable to do that? It is by going through some of the things that are present in the training platform. So when you as soon as you get your account, you will be able to get more insights on how all of these aspects work hand in hand to provide a safe working environment. All right. The next subsection after safety here is electrostatic discharge. I would like us to take a minute to reflect and say if we have any worry from the previous section. I would like each and every one of you to say something. If you do have one or you don't, just if you don't have something to ask as a question or a contribution, you just notify that. I'm going to start with Josh Amanda. Do you have any question or a contribution? While he's thinking, I'm going to proceed and ask Mrs. Mazule. I'm not sure if it's Mrs. Excuse me. Mazule, do you have any question or contribution? Are you present? Nevertheless, yeah, okay. Okay, just go ahead, go on. Any question or contribution? We can't hear you if you're speaking.
I don't have any questions. There are no questions. Everything is understood.
All right, that's nice. What about contribution? Do you have anything to add to what was said here?
No, nothing really.
All right. In terms of the speed of delivery, is the speed okay? Should I slow down or go a little faster?
No, everything is okay. The speed is okay.
Nice. I'm going to believe Miss Piewo Edith is a she. So you're coming in when we have gone a little bit far. We just finished the first subsection of the chapter 2 that we had to do today. Nevertheless, there is always a recording. You can always catch up. You're welcome. You're welcome to the class, Miss Piewo Edith. Do you have anything for us? Anything you want to say, Miss Piewo Edith? I believe this is your first session.
Good evening.
Good evening. Welcome.
Thank you. Yes, this is my first section. Is my first session, and I don't know how can I get the recordings, please.
The recordings will be shared with. Are you in the group? Are you in the group?
Yeah. Yes, I am.
Nevertheless, I'll enable that to find out if you are in the group. Immediately after every session we have, the recording is being shared to you as a link in the group chat, so you can always access it anytime. We'll make it available for at least a month. So even if you miss 3 classes, you can always catch up with the recordings, for they are available in the cloud for like 1 month. You can always get back to what we did in class.
Okay.
Yeah.
Okay. All right. Thank you very much.
You're welcome. The person with TechnoSpark 5 Pro, please can you change your name to, or present, like, let us know who you are so we can address you? And just before that, do you have any question? TechnoSpark 5. All right. We're going to proceed from here. The next subsection in this module is electrostatic discharge. Just as a recapitulation, in the previous module, in the previous subsection, we covered what is safety and how it is a top priority when you're working in a PC setting where you have computer components and devices all around you. How do you ensure your safety? We talked of a lot of measures, and we also talked about how do you fix or manage hazardous situations. Right now, we are moving on to electrostatic discharge. I want to believe that, I will believe that nobody here knows about electrostatic discharge, so I'm going to take it from the ground level. Now, electricity is capable of moving from one point to another through things that we call conductors. Now, what is a conductor? A conductor is any medium through which electricity can move with the least resistance. Some of the things, some of the components, some of the elements that provide conductivity for electricity are silver, copper, water. And we know that the human body is made of a high percentage of water. Hence, the human body makes a perfect conductor of electricity. Now, there is what we refer to as electricity buildup, static electricity buildup. It can be, it forms when you cause friction between when there's friction between 2 layers. So just when you rub the palms of your hand, there is friction and static electricity is being generated. What about you walking through a hall? There is, if you walk through a hall on a carpet, there is a type of electricity that builds up in you, which is referred to as electrostatic discharge. So I want to believe that that particular concept is understood. Electrostatic discharge is electricity that builds up in and stays in any conductive material, waiting to be transferred to a less charged component. So let me proceed by showing you this illustration. These are two bodies that are charged positively and negatively. That's static electricity. Static electricity is static charges. They are static charges, which means they don't move, they don't go anywhere. They are here on the spot. So when these two components now come and touch each other, electricity moves from one point to another. The positives here are called protons and the negative are called electrons. There is movement of electrons from one point to another. So when you find yourself having electrons moving from one point to another, it creates an instance of electrostatic discharge. So electrostatic discharge is where static charges move from one conductive material to another. I believe I explained that. Is there any question about what electrostatic discharge is? Electrostatic discharge, is there any worry, any question with that? Good. So you can see here that when these two individual conductors are present with their charge, their static electricity, and come together, electrons, which is the minus, all move to the least concentrated part, right? And when this happens, you find out yourself with two different two components that have different states of electricity. So you see now that the one on the left is totally negatively charged, while the one to the right is more positively charged. So there was movement of electricity. Now, let's say the one to the right is the PC, right? Let's say a memory chip in your computer, and the one to the left is you. You walk through a room and electricity build up in your body. When you get to the PC and you want to start, for example, doing your repairs or opening up to change something or dust, and by mistake, you touch one electrical component inside that PC. Current moves from your body to that component, and it might just be too much than the electrical component needs, which might damage it. So you need to know that the amount of electricity that is required to damage an electrical component is not even one that you as a human you can feel. So don't think that it is because you cannot feel that current that it is not enough to damage a component. This is why we always advise that you should not touch devices at the level of a look. If you look right here, you see these pins here. We always advise that you should not touch them with your hands, because you might have electricity build up in you that is just enough to damage these components without you even knowing. If you look from this illustration, okay, so sorry, let me just finish with the previous one before we move to the next. So electrostatic discharge is then when two components that are charged with static electricity come in contact. That creates a scenario of electrostatic discharge. Next, you have to understand that 12 volt is the maximum amount of electricity that is required to damage a memory chip or any other chip that is found inside the computer. And it is somewhere around 100 volts that the human body can feel electricity. On the regular electric outlets on your wall, the alternating current is between 110 to 112 volts, sometimes 220. But what you can start feeling is 100 volts, and 3000 volts is just enough to kill you. On the other hand, PC components don't even need 100 volts. They just need 10 volts to get damaged. That's why we advise that you do not touch electrical PC components when you have electricity build up on you. There are measures. You might not always know that there's electricity build up in you, but it's enough to damage this component. That's why we always advise that you use some safety precautions, some precautions or safety measures to avoid this scenario. We are going to talk about these measures, these scenarios, what you can implement in order to prevent damage, to avoid damaging these components. So first, we are going to talk about the fact that you can discharge yourself. This can be done by touching the metallic case, the PC case, the case of your CPU. So let's say you have a work scheduled at around 30 minutes and you're doing some other things around. And by the time you walk up to the PC, you might have the friction caused by you walking on the floor might have caused electricity build-up on you. So what you can simply do first is to touch the metallic case on your PC or any other metallic object to transfer the static electricity that is in you. No. Let me rather say this. Not just any other metallic object. Make sure that it is a PC case. This creates a scenario where there is an equal amount of electrical charges in your body and in the PC. There will only be movement between two components if there is imbalance in the level of electricity, right? So if you have here, let's look here. If you have here, how many? 4 protons, 4 electrons, 4 protons, 4 electrons. There is no electrostatic discharge because no movement is needed from one point to another, as both of them have the same amount of electricity. When they come together, there's no such thing as a discharge. But when you see now another component that has less protons, that is the one to the left, and you see the one to the right that has more protons and electrons than the one to the left. So there is supposed to be movement from one person to another. That is where, when they come together now, there is an electrostatic discharge that damages these components. By touching the PC case, it equalizes the amount of electrons and protons or electricity that is found, by touching the PC case, you will equalize the amount of electricity that is in your body and that which is in the PC case. So even if you touch a component, there will be no movement. There will be no movement, and hence there will be no electrostatic discharge. That's the first thing that you should do. There is also another component that we refer to as a static mat. A static mat. It is one component that prevents you from building up electricity that you can see, as you can see on this illustration right now. It is a component that will permit you to prevent electricity buildup both from you and both from the PC. This creates a scenario where you have the same amount of electricity as the PC itself. By discharging yourself, you both have the same amount of electricity. You don't want a scenario where as you're walking, there will be something that will happen and one of you will have more electricity than another. You will have to now create a discharge that might damage some components. So you use this mat to make sure that there is no additional electricity that builds up in one component than the other. I hope that's understood. Right. No questions. The silence means everything is understood. There is a static mat that you use for the PC, and there's an anti-static floor mat, which prevents you from getting electricity on the floor. So if you walk, or another way that you can implement to discharge yourself after walking through a hall, maybe to where you need to repair your PC, is by stepping on an anti-static mat, right? So which it's a mat that sends away static electricity. It prevents static electricity from getting to you. So it rather takes away the electricity that is accumulated or that has accumulated in you. You can see the illustration to the left. It's like a mat, right? The mat that causes friction, or as you walk on it, generates static electricity. And when you get to the PC you need to repair, in order to discharge yourself, you could either touch the metallic case of the PC, or you walk on, an anti-static mat. We said previously that while working on PC components, irrespective of the fact that you are discharged, irrespective of the fact that you're discharged, do not touch these electric pins. Reason being that there might be a very minute amount of electricity in you that you cannot feel, which can easily damage these components. So always enable to not touch the electric, this copper or diamond, these gold pins. Some of them are in copper, some are coated with gold, others are coated in silver. Do not touch them directly. You can see them here on a closer shot. You should not touch these connectors, these pins. Now, you'll find yourself having to store some spare parts. You find yourself at a point in time having to store some pieces, spare parts, working spare parts, so that if you have an issue, you can use that working spare part that you know to troubleshoot and find out if it is the component that is currently in the PC which is faulty, or it is just that the connector itself is not working. So in order to store these spare parts, something like a RAM, a graphics card, or stuff like that, what you need to do is you put it inside a static shielding bag. It is a bag that prevents buildup of static electricity. I don't know, it feels like I've said so much. We're already an hour into the class. So we are going to take 5 minutes from now before we continue to this next section. We're going to take 5 minutes of this to breathe a little bit, take a cup of coffee, or relax a little. Then we continue at 5 minutes past 8. In the meantime, if anybody has a question, you can bring it up. So 5 minutes from now is the time. We're on break. Hello, everyone. It's over 5 minutes, and we're going to continue from here. Right. So I will just state again the subtopics that we're supposed to cover within the class of today. And again, we had safety. Generally, the general chapter is about protection and the PC technician's responsibilities. So one of the sub modules was safety that we are going to cover. I'll just name those that we're supposed to cover. And it was safety, electrostatic discharge, ESG protection, and environmental controls. So right now we have already done safety, electrostatic discharge. We are finishing up with electrostatic discharge, and we're moving on to electrostatic discharge protection. That is ESG protection and environmental, then on the environmental controls. So I want to make sure everybody is back before we proceed. So I'll just call you by name. You just unmute yourself, just so I know you're there. Unmute and you mute back. You must not say anything. So I will begin with Mr. Etienne. You're welcome. You're welcome again. Mr. Etienne, are you there? George, Amanda.
Oh, yes.
All right. Mazule. Sorry if I don't pronounce your name well. I believe as we work together, I'm going to get the best pronunciation of your name. Really, pardon me about that. Nabila. All right, it's fine. Tecno Spark 5 Pro. All right, that's fine. You can meet back. Okay, so just before we continue, does anybody have a question? A question, a contribution? Does anyone have any?
I think I have a question.
All right, please go ahead. Please try being a little audible.
Okay, sorry to take you back, but this aspect of electricity, like you just said, we acquire electricity in our bodies. I don't get it.
All right.
I don't really understand it.
If I don't understand, if I don't understand your question, you don't totally get how we do acquire electricity in our body, right?
Yes.
Okay. Is that the only question you have, or you have any more? Just bring them together and we'll treat them one after the other.
And the discharge of the electricity also.
All right.
Like you said, you have to touch a metal or something or what to discharge the electricity we
I
have in our
understand.
body. So what I'm saying is, so the electricity we acquired in our body, is it dangerous to us?
All right.
How do we acquire it, and is it dangerous to our bodies?
Okay. Thank you very much for your question. I will start with how do we acquire this electricity, right? I'll start from there. I'll start from there. I believe you do understand that. Welcome, Ms. Nafisa. Welcome. Please just mute yourself while I address the question that one of our mates here just brought up. So I believe we do understand that life works in a way that it is mostly a place that has more that gives to another place that has less. If you have 1 liter of water and you have another bottle, which is another cup, which is exactly 1 liter, both of them are filled to stupor. To stupor means they are completely filled. Who is going to give to who?
The one that has more will give to the.
No, I mean like both of them have exactly 1 liter. All of them are filled.
Okay.
Who is going to give to who?
Neutral is nobody
Good.
will give to another person.
Exactly. There is a scenario of, there is a neutral scenario. Now, let me just excuse me. Let me do this. Let me do this. Right. So we have this one cup, which is completely full. And we have this other cup also. Don't mind the drawing. It's a cup. Both of them are completely full. If you have to give from, if you have to take this cup and put in the other, or take this one and put in the other, who is going to give to whom? Given that they are all 1 liter and all of them are completely full. Is it possible for one person to transfer to another?
No.
Okay, it isn't. Sorry if I'm confusing you. There is somewhere I'm trying to go to.
Okay.
If two cups have exactly the same amount of water, they cannot give to each other. What if this cup was like half? It was just like half filled. What if this cup was half filled and this other one is filled? You see that water can move from here to the other one, right?
Yeah.
Good. If this one was completely empty, water can still move from here to here, and this one will fill it to both of them have exactly the same amount. This same concept, what I'm just trying to make here is an analogy that is trying to explain how electricity moves from one point to another. If two conductors, what is a conductor again? It is any component or any material, anything that is capable of allowing electricity to travel through it with the least resistance, right? So
Yeah.
some of these conductors that we named were silver, copper, gold, water, and the human body we all know to have a high percentage of water. So it allows electricity to travel it with least resistance. Now, when you walk through a building, let's just say you're walking, the friction that you cause between your leg and the floor you're walking on, the friction that you cause is building up something that we call static electricity. Something is built up that we refer to as static electricity. Now, how does static electricity come about? It is created as you cause friction between your leg and the floor. The friction that is caused between your leg, let me say your shoe or your sock, and the floor, and that electricity does not go away. It is being stored in your body. That's where I attack the second question of which says, your second question says, is it not harmful to us? Remember, I said at the point in time that the electricity that you feel as a person, that you tend to feel, is over 100 volts. So it is when electricity is around 100 volts that you can touch it and actually feel like, oh, this is electricity. But PC components, these electrical components, what you currently have on your screen right now, they just need 10 volts to get damaged, 10 and above to spoil, right? Let me use the language I think you understand. So it needs nothing more than 10 volts to get damaged. Whereas you can only feel at some 100 volts. The electricity that builds up in you is somewhere anything between 0 and 15 volts. So it's not very much. You will never feel it. According to you, you don't have any electricity in you. You touch them freely, but you don't know that there's this minute amount of electricity which is sufficient to damage these components. I hope you understand. Good. So static electricity will build up in you. Remember, those components are off, so they don't have any electricity in them. As you walk through the room, you have built up, you have accumulated electricity. It is static, it is inside you, residing there. When you now move to this PC component and you touch it, remember the analogy of this cup which is full and the other one that is empty. When one that is full gets in contact with one that is empty, what happens?
There's transfer.
There is transfer, exactly. And that particular transfer there is now referred to as electrostatic discharge.
Okay. Okay.
Have you understood?
Very well. Thank you.
Good. Any further question?
No, no, no.
All right. Thank you for contributing.
Thank you so much.
You're welcome. Was the analogy well understood by all of you, or does anyone need any more explanation on something, any more concept? Any question, please, before we continue? Any question? Right. I believe we take them subsequently. We take the question subsequently. So clear this and we continue. In order to avoid electrostatic discharge, there are some particular types of bags that you can use to store your electric components in them. We call them static shielding bags. So if you have, let's say, your network interface card, your RAM module, your hard drive, or even anything that has chips that has components that can be easily damaged by the least amount of electricity, when you want to keep them, you can put them inside these bags. I think some of them are Ziplocs. I think you know what are Ziploc bags. They look like Ziploc bags, but we refer to them as static shielding bags. You could also use static resistant bags. They provide less protection than the static shielding bags, but they also work, right? They prevent the components that are stored in them to get electrostatic discharge. Also, while working with components or materials that you use to store your devices or your electrical components, avoid those of them that can produce static electricity. We are talking of plastic and styrofoam. Styrofoam is this thing that is white and chunky that you use to preserve like television or fragile stuffs when they are traveling. I don't know if you've ever opened the carton of a new TV, there is this white foam in it that TVs sit in them, irrespective of the electrical component you're purchasing. When they come new, they always sit inside this whitish foam. It is what we refer to as styrofoam. So they are capable of producing static electricity. So while working with PC components, electrical components of PCs, remove every static producing material around them. So summarily, we have discovered that electrostatic discharge harms PC components. They might not harm you as a person. They might not harm you. They might not be of any risk to you, but they do harm PC components. So always engage in measures that are going to avoid these components from being harmed or from being damaged. Next, we also talked about how to prevent electrostatic discharge. How do we prevent electrostatic discharge? We did say that you can use static mats by standing on a static mat. It prevents the electricity to build up again and dissipate within the workspace. We should also remove every static causing items. We just talked right now about the styrofoam and plastic. There are components that can produce static electricity, so you should remove them away from your working environment. And also maintain high humidity. Always maintain high humidity. You do know that what am I saying? You do know that environments that are very hot are likely to cause what are they going to cause? Dry environments causes friction. Dry environment causes friction, and friction produces static electricity. By preventing a very dry environment, like a completely dry environment, by making sure that your environment is not completely dry, it is kind of humid, you prevent friction. And by preventing friction, you prevent buildup of static electricity. You prevent the buildup of static electricity. So all right. The next submodule, this is the third submodule we had scheduled for today. We don't have much time left, so we're going to try to go through it as quick as possible. We will take questions at the end. we have less than 10 minutes. So we take questions at the end. So I'm just going to explain this part real quick, but in a way that you can understand. Nevertheless, you can always stop me if it is actually very, if you're not really understanding what is going on. You can always stop and ask me the question that you have. So the next subsection again is ESG protection. This refers to all the means, all the things that you can implement to prevent, to protect your device and yourself from electrostatic discharge. Remember, ESG stands for electrostatic discharge. One, you can use a static mat. It is a type of mat that equalizes or balances the amount of electricity that is found in two components. If you have 12 units of electricity and your computer has 8 units of electricity, 2 units are supposed to move from you to the computer so that both of you have equal amounts, which is 10. So at that level of balance, no electricity is moving from one person to another. So it creates a level of equilibrium, so preventing electrostatic discharge. So if you use a static mat, you prevent static electricity buildup. Next, use a static mat. There's a static this static mat to store your components. If you have maybe cables passing under the floor, the cables passing under your floor, and you just decide to keep your electrical component on top of that floor, there is this other thing that you're going to learn as you proceed within the next sessions. It is called EMI. EMI. I'll just type that in, and EMI stands for electromagnetic interference. It can also cause static electricity buildup, which can damage components. So always keep your electric components, this kind of fragile electrical components on a static mat. There is also another thing that you should implement, which is referred to as a wrist strap. A wrist strap. Remember in the very beginning, sorry for those who are not present, you're going to see that in the very beginning, we talked about an ESG wrist strap. Something that you wear on your wrist and connect it to the PC case. So always make sure that the amount of electricity that is found in you and in the PC case are at an equilibrium. They're at an equal level. There is no need for a discharge. So this wrist strap is not supposed to be connected when the PC is still plugged in the wall outlet. It's not supposed to be connected to your hand when electricity, when the PC case is connected to the wall, to the electricity that is coming from the wall. Because we said earlier that always make sure that you have disconnected your device from the electric outlet. So you just know what is going to happen if you connect this thing to your hand and plug the PC to the wall. You're directly linking yourself to short death. So one thing you should always make sure is that before you work on a PC, enable to disconnect the PC from current, and while working on sensitive components, wear a wrist strap, an electrostatic discharge wrist strap. So this is how it is being worn. It is worn here and connected to the PC case. You connect it to the PC case as you see. First of all, it is a static mat that is being connected with this alligator connector that you find here. Yeah. With this alligator connector, this is how we call it, this alligator pin. You can use it to connect it to, you put the case on it and you connect it to the use the pin to connect to the case, and you also use the pin that is found on the wrist strap to connect on the case. As you can see the setup, that's how it works. We are going to come back to this in a later time, for we don't have much time to discuss on it, but don't worry, it's nothing that is really, really serious. So environmental controls. This is the last submodule for our session of today. What is it all about? It is as we are going to see, so the skills that you're going to get by going through this submodule is how do you configure a UPS and how do you even install one? You might be asking yourself, what is a UPS? Unfortunately, a lot of you have not been able to cover very much inside a lot of the resources in the chapter, in the platform, the study platform. You were expected to have finished chapter 1 by today. So when you begin chapter 2, it is actually when you begin chapter 2, the presentation here is supposed to cover something that you have done already. So for every module that you cover, we do a presentation at the end of the week to make sure that you have understood what you learned in the platform. So we all incite you again to try to get yourself your licenses and start going through it. You're really going to like that platform. Nevertheless, let's come back to what we are talking on right now, which is a UPS. Can anybody tell me what UPS stands for? UPS. Anyone? Let anyone just tell me what is a UPS. I would like to hear from Miss Nafisa. Came a little late. Can you please tell me what a UPS is? Do you know? Do you have any idea? Miss Nafisa, are you there? Right, let me hear from the next person, Nabila. Please unmute yourself to speak if you're saying something. Yes. Do you know what a UPS is?
No, sorry, I got no idea about it.
Not even the meaning of the acronym?
No, never got
Anybody,
to know about it.
right. Can anybody help her with the meaning of UPS? If you don't mind, Miss Mazule, can you tell us, do you have any idea of what a UPS is?
Okay, a UPS, it means an uninterruptible power supply. It's just like a power bank where it stores energy, so in case there's power shortage.
That's wonderful. Thank you very much for that contribution. UPS stands for uninterruptible power supply. It is a type of backup battery that stays to help you, the user of a computer, to like it helps give you some time to be able to recover from a power outage by extending the time that you have to ensure a smooth shutdown. What am I saying? It is very likely that when you're working on your computer and electricity goes away, everything just shuts down. But you want to be able to you need a situation where you want to be able to like save what the things that you're doing. You want to have time to save the things that you're doing or round up with very important things that you had doing already. So the UPS is like a power bank, as she said. It provides you with electricity that is going to run your most essential devices. That is going to permit your most essential devices to like run for a certain amount of time that gives you down for a smooth shutdown. That's what we refer to a smooth shutdown as where you save all your work and you save all your progress before shutting down. Now, within the LabSim platform, you're going to learn how to actually configure a UPS, how to install one from scratch. You're going to do it. There are labs there that are going to permit you to implement all these skills. So we are just going to be talking about it here, but you're just talking about it, but actually you're going to do it physically. You're going to do them physically, and yeah. So thank you for your contribution. You can mute yourself. You can mute yourself so we continue. So I hope everyone understood what a UPS is. Uninterruptible power supply. Let someone should type it in the chat box, if you don't mind. Just type in the chat box. So yeah. The key terms that we're going to be discussing in this sub-module is line conditioner, standby power supply, uninterruptible power supply. You can see here uninterruptible power supply is the full meaning for UPS. Let's look at the definition. A line conditioner is a device that modifies the power signal to remove noise and create a smooth alternating current signal. So while your electricity is moving, while your electricity comes from your power company to your house, there is something that is called noise. Noise is any disturbance in common English But in terms of electricity, noise is any disturbance that creates irregularity in the electricity that is coming in from the power cable that is supplying your location. Uninterruptible, yeah. Sorry about the break. A noise is any irregularity in the power that is coming from the power company to your house. It could be, you remember, if I'm talking to somebody right now, and between the person and I, there's a loud sound of a loud source of noise, a loud source of music. That music creates a barrier that prevents the source, the destination of my voice from going. How will I say? It prevents my voice from going to the intended destination, right? So a line conditioner is a kind of device that provides a medium for smooth transmission of the signal from one point to another, which means if I'm intending to send a signal and I know that there will be noise somewhere, immediately after the noise, we implement the line conditioner. So it's going to stabilize the electricity that is coming in. I don't know if you've ever seen it, but on some chargers like laptop chargers or even some phone chargers, there is like on the cable will go smoothly, then out of a sudden you will see something black that bulges, that is round. It is like in a cylindrical manner. It's like a cylinder that is on the cable. It does not break the cable, but it is just there. That is like a line conditioner. I will get images and show to you subsequently. But for now, let's just stick to the fact that it removes noise and creates a smooth alternating current signal. Also, we have standby power supply, and it's an offline device that goes online to provide power when an undervoltage event occurs. Standby means it is standing there and currently monitoring for you, or monitoring the system to enable that as soon as there is a power outage or an undervoltage means that the electricity that is coming to you is not with the same intensity that it is normally supposed to come, right? So yeah, a standby power supply it's sitting there, it is offline, it is off, it is not working. But as soon as power goes off, or there is an undervoltage, we generally call it low voltage. As soon as it comes, that standby power supply kicks in and starts providing power to your devices until the power stabilizes or electricity comes back in case of a seizure. Now, we talk again about a UPS, an uninterruptible power supply. It's an online device that is constantly providing battery power to the computer and being recharged by the wall outlet. So a UPS is the one that is taking it is actually the one that is taking electricity from the wall and providing to the computer, to the devices that are connected. Let me just say devices. So once the UPS is taking that power and providing directly, it is also charging. It is also charging at the same time. So it is not just providing you power to your devices, but it is charging the backup batteries that are there, so that if electricity happens to stop, it automatically switches supply from direct current that is in the wall and to the battery reserve that it has. So that's how a UPS works. We have offline UPS and we have online UPS. So online UPS is that which is constantly providing power even when there is current, and offline UPS is the one that stays offline and when it comes online when there is a power outage or an undervoltage. I hope that is understood. Do we have any questions? Any questions? No, there isn't. So the next concept we are going to explore, do you have any question? Oh, something just occurred to me that to remind you, if you ever come with a scenario where you need to set up a UPS in your office, only connect key essential devices to that UPS. What do I mean? Connect just like your laptop or your desktop. Do not connect a laser printer. because the amount of electricity that a laser printer uses is it's enormous. It uses a very big, large amount of electricity. So if you connect a laser printer to your UPS, 5 minutes is the maximum time, depending on the quality of your UPS. 5 minutes is even much time, the UPS will be drained. So never you connect a laser printer to the UPS power source. Always connect it to direct current. Next, we are now looking at battery disposal. I just wanted to quote that so you know. You're going to still see them when you start going to when you go into the platform that is provided to you. We are now looking at disposal of electronic components. I believe we all know of alkaline batteries, these AA batteries and the other kinds. We are not supposed to dispose them off in the trash. Depending on where you are found, depending on your local laws, there are some provisions that are made for you to implement if you want to dispose these batteries off. Some states are going to, some states make it legal for you to drop it in the trash, but other states do not. Always make sure that you consult your local authority to be able to determine whether you need to deposit, you can deposit or you can dispose your batteries off in the trash or not. We also have lithium-ion batteries. These are reusable or rechargeable batteries. Lithium-ion is found in your laptop's battery. Lithium-ion is found in your phone's battery. And most of the times they can be reused. They can be reused, which means they can be recycled. So depending also on the laws that govern your local area, you can consider it, you have to consider before disposing of your batteries that do not work anymore. You can either be sending them to recycling facilities or setting them for disposal in some specific types of disposing units. So lithium-ion batteries cannot be put in common trash because they have toxic chemicals. So as I just said, there are some special types of collection bins that will be set for lithium-ion batteries or lithium-ion or components that have lithium-ion in them. Because of the toxic constituents of these elements, you have to dispose them in a special manner. So according to also the way your local rule dictates, you determine now which way is best suitable for you to dispose of your lithium-ion battery, but never in the regular trash. We also have printer cartridge disposal. So your printer cartridges are always recyclable. There is this concept that is called, I think, standardization, which means that every component of a PC is produced to a particular standard, right? So that you can start standardization and componentization. You will learn about it in the platform. I will also share any details about it if you need immediately after this session. Standardization and componentization. It implies that manufacturers of different brands should be able to produce components that will work in every single device, irrespective of their manufacturer. So I should be able to take a cartridge for, so let me say, I should be able to take a mouse that is produced for a Samsung computer and use it on an HP computer. I should be able to take a RAM chip produced by Samsung and use it in a Lenovo computer, in a Dell computer without facing any difficulties. If I'm using a Dell computer and my monitor just breaks down today, I should be able to walk into a shop and just buy another monitor, irrespective of the manufacturer, and just use it smoothly. So that was an aside, but just to let you understand the concept of componentization and standardization. You'll get to it, and by the time you get to this concept, if you have any difficulties, then don't worry, you can always get back to us and any of the administrators, and we're going to be able to throw some light on it. So printer cartridges. There are cartridges, there's some, for those who don't know what printer cartridges are, there are some specific units in a printer that contains ink. In some cases, we call them toner. That is used, we call the ink toner, that is used to print the colors or the text that we find on our papers. So once the ink inside is finished, some of them are rechargeable, which means you can just add more ink inside, whereas others need you to buy completely a new cartridge, right? So it is laser printers generally, inkjet printers. Let me not just talk about that for now. It's going to confuse you. You're going to learn that subsequently. So let's just say that when you're done with your printer cartridges, like the ink is finished inside, you should either recycle them, contact your manufacturers to refill the cartridges with ink, because recycled cartridges are generally less expensive. They will not charge you as much as, I beg your pardon? So you're not going to be charged as much for a refilled cartridge that as you'll be charged for a brand new printer cartridge. So always enable to recycle them. When they are no more in use, recycle it. Send it to the manufacturer to refill it, or you just send it to a recycling facility. If your monitor gets bad, don't just throw it in the trash. You should also send it to a recycling facility. These people have specialized equipments to use in order to, they have specialized equipments to implement on your damaged computers, on your damaged devices, to recycle them and make new value out of them. So let's say like this type of monitor, I believe that a lot of you have experience with these monitors. We refer to them as CRT, cathode ray tubes. Cathode ray tubes. There were this type of TVs that had a very long glass tube inside that used some kind of technologies to display information. These monitors have very large capacitors inside them. The same way we talked about the PSU, the power supply unit, to store electricity even when power is taken away. These monitors also have that have capacitors that are also as large as the ones of the power supply unit that can store electricity for a very long or an extended period of time. So you find yourself having electricity being stored in this monitor for even like 2 years. If you disconnect the TV from the wall and you don't use it, just keep it there. It can keep that electricity for as long as the TV is there. So if you try maintaining the opening it, you can get likely shock. And that electricity that is stored in these cathode ray tube monitors they are enough to kill a person. So you should, by disposing them off, you should send them to specialized facilities so that they can recycle, and give them new value, or they can properly dispose of these components as well, for those that need to be disposed of. Recycled computers, recycled materials also, they actually bring in revenue to those who are having them and try to reduce waste, and in general, it reduces the impact of electronics in the global warming. So we kind of bring in you assist in reducing the impact of global warming by recycling every electronic component that you have, because for one component that you recycle, there is one less component that is being produced in the factory. So the fewer the components that are being produced, the fewer the devices that are being produced, the more we enhance our planet and protect it from global warming and all the other environmental related issues. How do you discharge your electrical components? This is a power supply unit. We saw it in the earliest in the start, and yeah, you either discharge of it or by putting in some specific disposal methods, or you recycle them. You can see here, these are PC chips. These are chips from computers, like the memory chips, the processors, the motherboard, all of these. How do you recycle them? You recycle them by sending them to special facilities. Some of them, if you can see on these connectors, this is gold. This is actual gold. Gold is being used on connectors because it has a little resistance to electricity. That's why gold is being coated on electrical surfaces in order to enhance conductivity. So these electrical things have gold in them. That's why you have to send them to special facilities so that they can recycle by either taking out that gold to put in new components or for alternative purposes. In PC settings, always make sure that your temperatures are not very high. use the proper ventilation methods to keep your temperature at average level, that is 68 degrees. Sorry. So can you hear me? Sorry guys, there is just a little complication. I want to make sure you don't hear me. I will speak from here. So we're saying that high humidity within your work setting can cause condensation. Low can cause discharge. So the ideal humidity rate is somewhere between 40 and 60%. 40 and 60% is the ideal amount of humidity that you should have